Alright, this is for Pre-Cal 10, section 4.5, all about negative exponents. Quick review from yesterday with the fractional exponents. And again, we have our formula x to the power of m over n turns into the nth root of x to the power of m, or it can be written as the nth root of x, and the whole thing is to the power of m, either or. So we have 8 to the power of 2/3. This would turn into the cubic root of 8 squared. Always going to take care of your cubes first. The cubic root of 8 we know is 2, and 2 squared is 4. If we want to go in reverse, it's basically the exact process, just backwards. So we're going to take whatever is in front of your root and take the base number. So we're going to have 3.5. It's going to be a fraction. We know it's the denominator is 2, and the numerator is 3. When it comes to negative exponents kind of have a special rule to them. It doesn't mean you just take the, don't take the square root of 4 and then just make it negative. That's not what we do. It's going to give you the wrong answer. The simplified rule for this is if you have a negative exponent, really it's the reciprocal of x to the power of n. The only key here is x can't be 0. You can't have 0 to the power of a negative. And n should be a natural number. You can have it as a decimal, but if that is a decimal, convert it first to a fraction. So you'd have a fractional exponent and then solve. Our definition of reciprocal is whenever you take a reciprocal, you're basically going to flip your numerator and your denominator. If it's a whole number, it's basically over 1. So if it was a whole number like 4, and we take the reciprocal of it, it now becomes 1 over 4, because technically the number 4 is 4 over 1. If you have a regular fraction like 2/3, and you take the reciprocal, it just becomes 3 over 2. Whenever you have a negative exponent, to get rid of this, actually I should probably mention that over here. To take get rid of your negative exponent, you must first take the reciprocal and go from there. We did this a little bit in, I think it was chapter 7, when it came to parallel and perpendicular lines. So, whenever you have a negative exponent, it's really good to deal with your negative first and then deal with everything else. So, if we have 2 to the power of negative 3, before we take the cube or do anything like that, we're going to get rid of your negative 3 there. So to do that, we first take 2, and we basically take the reciprocal of that. So 2 turns into 1 over 2 is a reciprocal, and now the whole thing is to the power of 3. Then we can just solve it normally. We take our cube and we distribute it to both your top and bottom, numerator and denominator. We know that 1 cubed is just 1, and 2 cubed, 2 times 2 times 2, gives us 8. So again, always get rid of your negative first, then solve the rest of it. Pretty important. If it's already in a fraction, 2 over 3 to the power of negative 2, do the exact same thing, except you're just going to swap your numerator and denominator as the reciprocal. So this turns into 3 over 2, and now it's to the power of 2. We distribute that square into both, so we have 3 squared over 2 squared. 3 squared gives us 9, and 2 squared gives us 4. Always good practice. If you can reduce your fraction, you should, if you can. If you ever have a decimal, decimals are a bit tricky because what you want to first do is convert your decimal into a fraction. The best way to do this is think back to like grade 5, grade 6 math when it came to your fractional math, and just think about how you can break apart 1. So I know that 0.2 or 20%, right? 20% is the same thing as saying 20 over 100, and then you can just basically reduce that down. So that's the same thing as saying if I take out 10, that's 2 out of 10. If I reduce this down, that's 1/5. So I know that 0.2 as a fraction is 1/5. So we're going to start at 1/5, to the power of negative 5. Then when I get rid of my negative exponent, I'm going to swap my numerator and denominator. So this now becomes 5 to the power of 5. Technically it's 5 over 1, but it's over 1. And 5 to the power of 5 is a pretty large number. I think that's going to be in the thousands. So 5 to the power of 5 is 3,125. I find the hardest part with all this that students really run into is just turning your decimal into a fraction. Before we get into the homework, one thing I do want to mention is later on we're going to get into fractional exponents that are negative. So if I have, we'll say 3 over 2 to the power of 3 over, oh, that's a bad example. Let's go 5 over 7 to the power of a negative 2/3. We won't solve this yet, but a lot of students can remember, okay, I have to take the reciprocal, and what a lot of them do is they say, and they swap your exponent, and they'll go, I'll take the reciprocal, well that just means it's to the power of 3 over 2, and that's not what you want to do, because that will give you the wrong answer. You want to make sure you flip your whole number you're dealing with. So this will be 7 over 5 to the power of 2/3. Probably the most common mistake I see. Easy to fix, but also easy to fall into. For 4.5, that's it. And you'll see that I've given you guys, surprise, surprise, a fractional exponent. We'll try these out. So, 27 to the power of negative 2/3 is question 1. Question 2 is 9 over 16 to the power of negative 3 seconds. If you have any questions, I will be online Tuesdays and Thursdays for tutorial. Otherwise, good luck.